Hi grade 7th. This is our tutorial session on solving algebraic expressions using Xbox. And I would like you to have your Xboxes made and some pennies available for you to work through this tutorial with me, please. So if you don't have that, please turn off this recording and go and get that organized and then turn it back on when you've gotten everything organized. So first of all, what is an Xbox? An Xbox is basically a tool that we're going to use to help us learn about and solve algebraic expressions. And we've learned quite a bit about the different parts of algebraic expressions already, and we know that we use a small or lowercase letter as a variable in an algebraic expression. So we're going to let our Xbox, and mine is a little muffin cup, be our variable in our algebraic expression. And of course, we know we can have various numbers of x depending on our coefficient. So if we have 2x, then we would put 2 Xboxes in. If we have 3x, then we would put 3 Xboxes in. 4x, we would put 4 Xboxes in our pattern, etc. So we're going to be using these Xboxes along with a bunch of pennies to help us solve these problems. Okay, so the first thing to understand is that the value of our algebraic expression depends on the number that we assign to the variable x. So we're going to be giving x a number, and we're going to use our Xboxes to solve algebraic expressions for a specific number. So let's start doing that, looking back at the whiteboard. Let's take the expression 3x. So that coefficient 3 is telling us that we need to have 3 Xboxes. So I've got them there. So the first question, what is the value of the expression if x equals 1? So x equals 1 means that each Xbox gets 1 penny. So let's put 1 penny in each Xbox. And what is the value of this expression if we have 1 penny in each Xbox? Let's just empty that. Count the number of pennies we end up with. And if x equals 1, then 3x is equal to 3, because we have 3 pennies there. Okay, let's try it again. Next we have what is the value of the expression above of 3x if x is equal to 2. So in this case, they're telling us x is equal to 2, so we're going to put 2 pennies in each Xbox, and of course empty those out, and we have 6 pennies, so we can write then 3x is equal to 6. And I think you can see where we're going with this. We have x is equal to 5, then we have to put 5 pennies in each Xbox. Okay, so we have 5 pennies in each Xbox. Let's empty those out and see what the value of our expression is, the total number of pennies. So we have 15 pennies there. So if x is equal to 5, then 5x is equal to 15. Okay, pretty simple, right? But not all of our algebraic expressions are that simple. We're starting simple here, and then we're going to move up to more complicated. Let's try one that's a little bit more complex. We have the algebraic expression x minus 1. So there's a single x there, so we would put in a single Xbox. Okay, and we're asked to solve the expression x minus 1 for x is equal to 1. So if x is equal to 1, we put 1 penny in our x box. Let's just empty that out. Now, after we've emptied out the x box, they're saying it's x minus 1. So if it's minus 1, we need to take that penny away. So how many pennies do we have left? Left is 0. So if x is equal to 1, then x minus 1 is equal to 0. Let's do the same thing for x equals 2. Put 2 pennies in our x box. Get it emptied out. Now we have to subtract 1 because our expression says whatever's in the x box, subtract 1. So we have 1 penny left. So then x minus 1 is equal to 1. And again, this pattern is pretty clear now that we know how to do this. If x is equal to 5, we're going to put 5 pennies, and notice that we still have a single x box there. X is like saying 1x. Let's empty it out. We have 5 pennies, but it's less 1. So we have 4 pennies left. 1, 2, 3, 4. So if x equals 5, then x minus 1 is equal to 4. Okay, let's do some where we combine our variable and a coefficient, and we have a constant. So this expression has a coefficient and a variable and our constant 1. So the expression says 2x, coefficient 2, so that means I'm going to need 2 x boxes to solve this. And now let's start solving. As soon as I got my number of x boxes in there, I can start solving. So we're solving for x is equal to 1. So I put 1x in each of my x boxes, and I'm adding 1. So let's put 1 penny in there as my constant. And what's my total? Let's empty out my x boxes and find out my total. X is equal to 3. So for x equal 1, looking back at the whiteboard, then 2x plus 1 is equal to 3. Okay, what about if x equals 5? Okay, our expression is still 2x. So we have an x box for each x. And if x is equal to 5, then I'm going to put 5 pennies in each x box. Got an American penny in there. For anyone in our class who's American or living in the States right now, should put some pesos in someday too. Maybe some euros. Anyway, we have to add our single penny as our constant. So the number of pennies now is equal to the value for that expression. So let's empty out our x boxes, count the total number of pennies, 2, 4, 6, 8, 10, 11. So if x is equal to 5, then 2x plus 1 is equal to 11. And finally, let's do this for x equal 8. I would like you to try this yourself. And then turn on the recorder and check and make sure you got the right answer. Don't forget to write out the full answer. So you're going to be writing, if x equal 8, then 2x plus 1 is equal to, and then put your answer in after you've solved it with your x boxes. Okay, so let's see how we did. So we still have 2x, because there's 2 x's in our expression, so 2 x boxes. And let's put our constant in first this time, 2x plus 1. And we're solving for x equals 8, so we need 8 pennies in each x box. Okay, so now the total number of pennies has to be equal to the solution to our problem. Get them in order here so we can count them easily. If x equals 8, then 2x plus 1 is equal to 5, 10, 15, 17. Okay, so that's how we use X boxes to solve for a number in a specific expression.